Alright, this is Unit 6, Lesson 2. Today we're going to be working with rational expressions some more, but this time we are going to be adding and subtracting them. So after the Unit 5 test, I had you work on remembering how to add fractions, and we had things like 1/5 plus 2/5, and hopefully you recall that in this case, because these two fractions have a common denominator, this would be 3/5. So 1/5 plus 2/5 is 3/5. It works the same with rational expressions. If we have 4 over 2x and we want to add 3 over 2x, we can totally add those two things together. It's 7 over 2x. And we added or combined those numerators and the denominator stayed the same. Adding rational expressions works just like adding regular fractions, and in these two cases it worked that we could do that because we had a common denominator. So I want to have a couple examples that have a common denominator here. So here we have x over x plus 4. We're adding 3 over x plus 4. Well, if we combine those numerators, it would just be x plus 3. There's nothing more we can do to combine those two terms, and our denominator would stay the same. It will be an x plus 4. So this would be our solution, and there's nothing there that can be simplified. This other example, the denominator in both of these fractions is x minus 2, so we can combine the numerators. 6x minus x, and that's a 1x, so our numerator would be 5x, and the denominator would stay the same. And again, there's nothing we can really do to simplify that. It's as simple as it gets. Okay, one more. This one I had them try by themselves, so if you want to pause the video and give it a shot, and then you can check your answer. The denominators here are the same, x squared plus 2x minus 3. And because those denominators are the same, we can go ahead and combine the numerators. We have an x plus 4, and we're subtracting 1, so that would be x plus 3. Now it turns out this one does simplify a little bit. In the numerator we have x plus 3. In the denominator, if we factor that, we have x plus 3 and x minus 1. So one of those factors of x plus 3 can be reduced. So our final answer would be 1 over x minus 1. What about this one? If I have 1/2, so I'm adding the fraction 1/2 to the fraction 3x plus 5 over x, well, we can't add it yet because we don't have a common denominator. So in order to be able to add this fraction, we have to adjust it or modify it to make it have a common denominator. So I want to remind you how to do this with numbers, and then we'll look at it with our rational expressions. We have the fraction 1/3 and we have the fraction 3/4. So we think about what common denominator these two fractions could have, and hopefully you see that that common denominator is going to be 12, because the number 3 and the number 4 are both factors of the number 12. 12 is called their least common multiple. So 1/3 plus 3/4, we need a common denominator of 12. Well, right now this one has a 3, so we need to times it by 4 to make it 12. And we can't change the quantity here, so we have to times it by 4 over 4. It's just a fancy number 1. So the quantity that this becomes is 4/12. That's the same as 1/3. We haven't changed the quantity there. It's just in a different form, but it's exactly the same amount. The 3/4 on the other fraction, we need to times that by 3. Now we have to do it in the numerator and the denominator. Again, it's just a fancy number 1. So we're not changing the quantity, We're just changing what form it's in. We want it in the form 9/12, which is exactly the same as 3/4. So now that we have a common denominator, we can go ahead and combine or add those numerators together. The denominator stays the same. It's 13/12. So we're going to use that same idea to help us add rational expressions. So we have this same example I showed you before. 1/2 is our first fraction, and we're adding 3x plus 5 over x. So we have one fraction that has a denominator of 2 and another fraction that has a denominator of x. Well, we need to have both of those factors represented in our common denominator. So that common denominator that we're going to try to get is going to be a 2x. Well, our first fraction already has the 2. It's already there. To have this one have a denominator of 2x, we need to multiply it by x. And again, we have to do that in the numerator and the denominator because we don't want to change the quantity. X over 2x, or 1x over 2x, is exactly the same as 1/2. We haven't changed what this is. We've just modified it and put it in a different form. A little bit more complicated for a minute so that we can add it. So that first fraction is now an x over a 2x, or a 1x over a 2x if you like to have that one there. Well, our second fraction, it already has the x. So we need to times this one by 2. Well, if I times this by 2, I have to make sure both parts of that numerator get multiplied by 2. So it's going to be a 6x plus 10. And now it has a denominator of 2x. Okay, so these two fractions that I have here are exactly the same quantity, exactly the same amount. They're equivalent to the fractions above. They're just in a slightly different form that now gives me a common denominator so that I can combine them. This will be a 7x plus 10 over 2x. So we're going to go through a couple more of these because a lot of different maybe scenarios come up with different denominators, and you have to be able to start recognizing what the common denominator is going to be. So we're going to just go through a couple of examples, and then there's no other new concepts today, just this idea of how to find a common denominator, modify the fractions, and then go ahead and add them. Okay, so this one has a 3 over x minus 4, and we're subtracting a 2 over x. Well, my first fraction has a factor of x minus 4 in its denominator. That is going to have to be a part of my common denominator. The second fraction has a factor of x. That also is going to be part of my common denominator. I need both of these factors here. Now, brief aside, sometimes people want to do things like write a minus 4 here. Now, that doesn't work. And the reason that that doesn't work is because, remember, we are multiplying or trying to multiply by a fancy number 1. So if we decide to just put that negative 4 there, this fraction would become a negative 4x and in the numerator a negative 8. Now, it's definitely true that 2 over x is the same as negative 8 over negative 4x, but it's not helpful in the context of this problem because we're trying to get the denominators the same, so it didn't help us. Okay, so try to avoid that error of thinking that a negative 4 is going to make those two denominators the same. It won't. These two denominators really are just two completely different factors. So we have to have both of those factors represented in our common denominator. Okay, so we want a common denominator of x times x minus 4. This first fraction already has the x minus 4. So we're going to multiply this one by x over x. So that means my first fraction is going to be a 3x over an x times x minus 4. Okay? Second fraction already has the x. It already has this part. So what it needs is a factor of x minus 4. So if we go ahead and think about distributing that 2, we're subtracting 2x minus 8 over x times x minus 4. Okay, so we've put our two fractions into equivalent forms. So now that they're the same, we haven't really changed the fractions, we've just written them in two different forms so they have a common denominator. We can now combine them. Our denominator is going to stay the same. The numerator, we have to be a little bit careful here because it's subtraction. So this subtraction is going to apply to the 2x, and it's going to distribute to that 8 so that it's a positive 8. Okay, so what we're going to end up with is we have a 3x, and we're subtracting a 2x. So that's going to give us just 1x, and then we have this 8. So x plus 8 over x times x minus 4. Now it's not wrong to distribute that denominator. That's a fine answer as well. It's just not necessary. I usually just prefer it if you leave that denominator in factored form. So there's no need to multiply that out. But if you do, it's not wrong. All right, let's look at another one. So we have a 7 over x plus 4, and we're subtracting 2. Well, the number 2, sometimes it throws people because it's not a fraction. But we could always think of it just as 2 over 1, if that is helpful to you to see that written as a fraction. So if we think about what factors are present in denominators here, we really just have an x plus 4. Now, if you want to think about it as that there's also a 1, that's fine, but we don't really need to write the 1 there because it's not going to change that denominator. 1 times x plus 4 is exactly the same as x plus 4. So that first fraction does not need any modification. It's fine. We don't have to change it at all. It already has the denominator that we want it to have. But we do need to times this one, and we're going to use x plus 4 over x plus 4. So now the second one that we're subtracting also has a denominator of x plus 4, and its numerator is a 2x plus 8. Okay, we're subtracting, so we have to be a little bit careful with our sign. This negative is going to apply to the 2 and apply to the 8. It's going to distribute to both of those. So now we can combine them. Our denominator, of course, is going to stay the same. We have a 7 and a negative 8. That's going to be a negative 1, and the negative 2x, of course, will be part of that as well. Now again, this negative 1 right here came from 7 minus 8. You could, if you want, factor that negative 1 out. It's not necessary, but you can if you want. A lot of times on the answer key for the homework, I have the answer, the numerator factored if possible. Your answer is not incorrect if you leave it like this. That's fine, but this is maybe the one that you'll see on the answer key. So don't panic if yours is a little bit off from mine. It's okay. All right, another one. Here is two fractions that we want to add, x plus 4 over x minus 1, and we're adding 5 over x squared minus 1. Well, right now it's pretty clear that the denominator of this one is x plus 1. That's fine. But over here, we have a quadratic. We have two factors in the denominator there. I'm going to move this up a little bit. So for just a minute, I want to focus on that second fraction. I'm just going to rewrite that first one. Because this right here has two factors in it. We have a factor of x plus 1 and a factor of x minus 1. So when we look at this now, you can see that both of the fractions already have an x minus 1. We definitely are going to have x minus 1 as part of our common denominator. Both of them have that already. But the second one also has a factor of x plus 1. So we're going to need that as part of our common denominator as well. Well, the second fraction already has both parts. So we don't need to adjust it at all. It can stay just the way it is. It already has the common denominator that we wanted it to have. Oops, sorry. But we do need to modify this first fraction. To get a common denominator of x minus 1 times x plus 1, we need to multiply this fraction by x plus 1. So our numerator is x plus 1 times x plus 4. Our denominator is x plus 1 times x minus 1. They are now the same denominator. So we can go ahead and combine them. As I combine them, I'm going to go ahead and multiply that out and put it into standard form. And the reason that I want to multiply that out and put it into standard form is so that I can combine it with that 5. If I don't multiply it out, it's not going to be able to combine with that 5 very well. So let's go ahead and multiply that out. We have an x squared. There's a positive 4x and a positive 1x for a total of 5x and a positive 4. Okay, so right now we're combining our two fractions. We know that that denominator is going to stay the same. And we've multiplied out that fraction's numerator on the left-hand side. On the right-hand side, we just need to add that 5 to combine those two. And at this point, we're really close to being done. We just need to combine these two terms that are alike. So our final answer would look like x squared plus 5x plus 9 over x plus 1 times x minus 1. And there's not really anything we can do to simplify that. You could always look at this quadratic and see if you could factor it, but x squared plus 5x plus 9 is not factorable. So we're done with this one. Okay, we're going to look at two more. I'm trying to show you maybe some of the different combinations that are of denominators that might come up so that as you're doing your homework, you'll maybe have something to look at that might help you. So we have two fractions here. The two fractions have factors in the denominators that are completely different. We have an x minus 9 and an x plus 1. So our common denominator has to represent all of those factors. So we have the common denominator x minus 9 times x plus 1. Okay, well our first fraction already has the x minus 9. It just needs the x plus 1. So this becomes, and I'm going to go ahead and multiply it out, because the only way I'm going to be able to combine it with the other fraction is if it's in standard form. So we get an x squared, we have a negative 8x and a positive 1x for negative 7x, and the constant's going to be a negative 8. So this is my first fraction. We're going to subtract from that, put it in black here. Well, that second fraction, if you look at it, it already has the x plus 1. To be the same, it needs the x minus 9. So if we multiply that out, we would have, let's multiply that out. This fraction is x squared minus 9x plus 2x is negative 7x. minus 18. And of course, we have the denominator x plus 1 times x minus 9. So we've modified each of those fractions so that they have a common denominator. We can now combine them. We're subtracting here, so we have to be a little bit careful. This subtraction is going to distribute to each of these terms. This will become a negative x squared, a positive 7x, and a positive 18. So as we combine, we have an x squared here, and we have a negative x squared. That means there are 0 x squareds in my answer. We have a negative 7x and a positive 7x. That means we have 0 x's in our answer. And then finally, we have a negative 8 and a positive 18. So when we add those together, we get 10. And of course, our denominator stays the same. So that would be our final answer. And one last example. So this one looks a little bit complicated, and this one is probably one of the hardest cases for most people. We have to figure out what common denominator that we want to use. Well, in order to figure out what common denominator we want to use, we need to know what factors are present in our current denominators. So let's factor this denominator. X squared minus 3x has a common factor of x, and if we factor it out, it has a factor of x minus 3 there. Our second fraction in the denominator, if I factor it, it just has a common factor of 5. So if we factor that 5 out, we have an x minus 3. So now that we can see the factors of these two denominators, you can see that they definitely need an x, because there's an x here. They definitely need an x plus 3, or sorry, that's a minus x minus 3, because there's one of those there. We need a 5, and there's the 5, and we already have the x minus 3 represented. So our common denominator is going to be 5x times x minus 3. So as we're looking at our two fractions, you can see that the first one already has the x and already has the x minus 3. It needs to be multiplied by 5. So this first fraction becomes 5 over 5x times x minus 3. So we look at our second fraction and think how we need to modify it. It already has the 5. It already has the x minus 3. The only thing it's missing is the x, which needs to distribute. So that fraction becomes x squared plus 2x over 5x times x minus 3. So we have a common denominator now. We just need to go ahead and combine them now. Our denominator is 5x times x minus 3. We have a 5 plus an x squared plus a 2x. I'm going to go ahead and write that in standard form, and we are finished. Okay, this process is a little bit tricky as you're learning it, so if you need additional help, please come in and talk with your teacher before school or after school or at lunch, and we will be more than happy to help you. You will totally get the hang of it, though, after you've done a few and practiced it a bit. Thank you.